We're going to start focusing on similar right triangles for the rest of the week. So let's do some review on Pythagorean theorem and what makes a right triangle. In a right triangle, you have a 90-degree angle measure. The longest side in a right triangle, the side length opposite that 90-degree angle measure, has a specific name. What's that longest side in a right triangle called? It starts with an H.
Hypotenuse.
This is the hypotenuse. So in this figure, with sides A, B, C, which one's the hypotenuse? C. The right angle measure is in the lower left corner, so wouldn't this right side be the hypotenuse? Because it's the longest of all three sides. It's opposite the right angle measure. It's called the hypotenuse. H-Y-P-O-T-E and U-S-E, hypotenuse. The other two sides that form the 90-degree angle measure, the other two sides that are shorter than the hypotenuse, are called the two legs. A and B are each called the two legs of our right triangle. Typically, one leg is shorter than another. A long leg, a short leg, the hypotenuse. So the relationship for the side lengths in right triangles is called Pythagorean theorem. For a right triangle with legs A and B and hypotenuse C, A squared plus B squared equals C squared. The length of A squared plus the length of B squared equals the length of the hypotenuse C squared. We're going to need to use Pythagorean theorem to work with similar right triangles and solve proportions starting tomorrow. So let's just do some quick review. Draw a right triangle here for our first example. Directions say this: find the missing side length using Pythagorean theorem. Answer in simplest radical form. So in our first right triangle, I have two sides labeled 4 and 10, and the third missing side left over for us to find. That third missing side, is that a leg or hypotenuse? Hypotenuse. So let's label that as letter C, where A squared plus B squared equals C squared. The other two sides, the 10 and 4, I'll call A and B because they're the two legs. A I will call 4, 10 we'll call B, but of course those are reversible. I could have just easily said B was 4 and A was 10. Doesn't much matter. So Pythagoreans is going to tell me that 4 squared plus 10 squared equals C squared. What's next? What operation says start where? Exponents. So tell me what's 4 squared? What 10 squared, bud? 100. 16 plus 100 equal to C squared on the right. 100 plus 16 makes 116. I'm left with 116 equals C squared. I need to solve for C. I have C squared. What's going to get rid of that square? Give me a good start here, Emma. What's the opposite of squaring something? I'm dividing. Square roots. The square root cancels out the square. So my hypotenuse length, C, is equal to the square roots of 116. That's not fully simplified. What I don't want you to do is type that into a calculator and get some god-awful looking decimal. I'd like to factor this using simplest radical form. What perfect square would divide into 116 that I could use to simplify it? Perfect squares are like 4, because 4 is 2 times 2. 9, because it's 3 times 3, and so on. Is anything divided into 116 that I could use? 4 how many times?
29.
What's 116 divided by 4? 29. But of course, we chose the square root of 4 because what is the square root of 4 really reducible down to? 2. Circle that, it's simplified. 29 is prime, so I think we're done there. Multiply those back together for our final answer, and it's 2 root 29. Hypotenuse has a length of 2 radical 29. How about one more, just so we get some more good practice? Same sort of setup. I have a right triangle with two side lengths labeled as 5 radical 3. The third missing side is the one on top. What side length are we trying to find? A leg or hypotenuse? Hypotenuse. So once again, we're asked to solve for C when I'm given the two legs A and B. So 5 squared plus 5 radical 3 squared equals C squared. Kara, try me this. What's 5 squared? 25. How do I take 5 squared of 3 and square it? What's 5 squared of 3 times 5 squared of 3?
5 squared of 9.
What's the square root of 9 though, Tristan?
3.
What's the square root of 3 times the square root of 3? 3. That's one pair of numbers to multiply. Don't forget to also find 5 times 5. 5 times 5 is 25. Square root of 3 times the square root of 3 was 3. So now multiply those pair of numbers together. Multiply the first pair, multiply the second pair, then take those two and find the final product. What's 3 times 25? 75. 5 squared of 3 squared is 70. That gives me 75 plus 25 equals C squared. Add those up, and now I've got an even 100. How about we square roots again? Square root of 100 is nice because what's the square root of 100?
10.
10 on the nose. Awesome. That will be a nice tool for us to have in our back pocket when we start looking at similar right triangles tomorrow.